Good morning, guys. And in this today's session, we are going to see about the memory types. So, before going to the presentation, we will be seeing the resources are made from varieties of books. So, particularly a Rajkamal book and online PPT that were available on the internet. The purpose of PPT is made for the classroom teaching. So, nothing other than we are not making money, and this is purely educational purpose. So, so today's agenda, we are going to see with the classification of memory types and memory maps and addresses. So, before entering into the session, first we must know what is available in our credit card. As in the present scenario, we are moving towards the Wi-Fi enabled card. So, in olden days, we will be having the Visa card, and which is having the 2 kilobytes of RAM, and which has a limited encryption cryptographic technology. The cryptography is that kind of encryption made in the card to hide the account holders and the accessibility to the cards. And nowadays we are moving to the M and chip based card. And this chip holds 32 kilobytes of memory, so which is far better than the old and magnetic strip card. Mm, and also the improvement over the certain encryption technology in order to hide the owner's information from accessing by the other people's other than the banks. So the first thing first, the memories are classified as a primary memory and secondary memory. So in embedded system, we are classifying it as a RAM, ROM, EEPROM, and many other types. So first, the ROM. It uses and its variants. The ROM is a non-volatile memory. So no, the meaning for non-volatile is whenever the power goes off, it will retain the information whatever it's being stored, so useful for embedded codes and data in the system. So mostly termed as a masked ROM, PROM, OTP-ROM, and EPROM and EEPROM. So the broadcast we'll be seeing the masked ROM, EPROM, EEPROM, and OTP-ROM, and uses of ROMs and EEPROM or flash. Masked ROM. So it is built from the circuit that has the R input and 8 output. So mostly it's a kind of a combination circuit. The certain few link fuses and others do not do. The program will be provided to the manufacturing foundry. The program will be provided to the manufacturing foundry in when it is coming to the customer. It is already programmed while manufacturing the chip itself. The other manufacturers, such as for example, if the manufacturer is the NXP Semiconductors, they will be and myself is a concern named as a XX company, and I'll be giving my source code to the NXP, and they'll be programming in the manufacturing itself, and there is no need for reprogramming it because it needs a huge it involves a huge cost in programming the ROM in our premises. So that will be giving an order of 1,000 pieces of ROM will be a cost effective, at least 1,000 pieces. So EPROM and EEPROM and OTPROM. The EPROM, it is an ultraviolet ray erasable and device programmable logic programmable read-only memory. Erasing the device means restoring 1 at each bit in the cell array, and 0 means there is some memories being there, and 1 is clearing all the memories at each ROM address. The EEPROM erasing during the application and program run is done by sending all 8 data bus bit as 1 for right the presence of presence. If the input of VPP, that is the voltage pulse, it may be a 5 voltage or a 12 voltage programming voltage for a short write pulse. So we'll be programming by applying some voltage pulse to the fuses. Next one is the flash memory. It is a form of the electrically erasable programmable read-only memory, in which the sectors of bytes can be erased in a flash. The very short duration of the single clock cycle. The advantages over EEPROM is that erasing of many bytes simultaneously saves time in each erase cycle that precedes the write cycle. The disadvantages is that once erased takes more time in writing in. The programmable read-only memory and OTP-ROM is in another form. Once written, it is cannot be erasable, the programmable read-only memory. And OTP-ROM is a one-time programmable read-only memory. So in my premises, if I'm going to program it, I can program it for only once. I cannot make a further programming again and again. as like your flash memory or electrically erasable programmable read-only memory or electrically programmable read-only memory that is made by ultraviolet. So this is all about the ROM. The uses of ROM or EEPROM or flash. The electrically erasable programmable read-only memory is usable by erasing over 1 million times. It can be erased during the runtime itself. The flash memory is usable about 10,000 times for a repeated erasing followed by programming during the runtime. The programmable read-only memory is a writer once by a device programmer or by first system run. The three examples of electrically erasable programmable read-only memories are storing the current date and time in a machine, storing the port statuses, and storing driving malfunctions and failure history in the automobile for use by mechanics and later on. Next, we'll move to the RAM. The various forms of RAMs are SRAM, DRAM, NVRAM, and EDO-RAM, SD-RAM, RD-RAM, parameterized distributed RAM, and parameterized block RAM. The SRAM, that is a static RAM, is used most commonly for designing the caches and in embedded systems and microcontroller. So the SRAM is most commonly used for designing the caches. The cache memory is another temporary memory which makes the system as faster when we open the same application again and again. The dynamic memory is used mostly in high performance computer and high memory density system. The EDO RAM is used in system with buses to devices when operating with a clock rate up to 100 MHz. The SD-RAM synchronizes the read operation and keep the next word ready while the previous one is being fetched. The RAM-bus dynamic read-on area random access memory access is the bus for four successive words in a single fetch, thus gives a 1 GHz performance of the system. When compared with the SD-RAM, the RAM-bus dynamic RAM will give the burst of four words. So it can be used for a high performance system, such as graphic intense systems. Parameterized distributed RAM is the RAM distributes in various system subunits. The I/O buffer transceiver subunits can have a slice of a RAM each, and the system stack can be at another slice. The distribution provides a buffering of memory at subunits before they are fetched and processed by the processor. It facilitates faster inputs from the I/O devices than the process system buses access the I/Os using the system memory. The parameterized block RAM is used when a specific block of RAM is dedicated for a use by a subunits only. For example, a Mac unit. A parameterized block RAM is used when accessed by a system or a I/O or an internal bus is slow compared to the processing speed of the subunit. So that's all about the basic characteristics and types of memory units for any kind of embedded system. And thank you for following me. And this is about the end of the session 3, and we'll be seeing in the session 4 in another good day. Thank you.